Hi guys, welcome to NextOps channel. This is the fourth video in the series of Azure Interview Preparation 5 module course. In the previous video, we discussed about virtual network leftover options. And in this video, I'm going to discuss about storage specifically. Before we move on to actual discussion, I would like to introduce myself. My name is Charan and I'm working in IT since 13 years. I'm a certified professional of Microsoft, VMware and Azure. I do a lot of automation on a daily basis, and because of that reason, I love it and I like to explore new technologies. If you want to reach out to me, you can send me an IM on LinkedIn or drop me a comment on my YouTube channel. If you haven't subscribed to my channel yet, please go ahead and do that now to receive the updates via notifications. And also don't forget to click on the bell icon. Let's move on to the discussion. In this module, I'm going to cover about Azure storage accounts, blobs files, queues, tables, managed disks, service endpoint example that we left in the previous session. All right. So Azure storage is more of theoretical stuff. So once we understand theoretical stuff, then it's all about configuration. So what is a storage account? Storage account is a traditional management way of storage in Azure, basically. So now they have come up with a solution called managed disks. So we have two options now. One is storage accounts and one is managed disks. So in the case of managed disks, there are no storage accounts, no more. Everything will be maintained by Microsoft in the background. But in the previous or earlier version, we used to create storage accounts in which we used to create containers, in which again we'll be creating blobs, files, tables, queues, etc. So when you create a storage account, there are four types of storages, blobs, files, queues, and tables. So if you want to store massive size objects for your media or massive data, then you need to use blob kind of storage. Blob stands for binary large object. Files are nothing but the traditional CIF shares we use in Windows environment, but this particular CIF shares will use assembly version 3 server message block protocol version 3 for the access, but we do mount them as regular CIF shares once we create the files on Azure side. Queues are used for, it's a messaging platform, generally used for sending notifications to mobiles and handling transactions in the e-commerce website, something like that. So anything that is being processed in the pipeline can be handled using queues. I can't show a real-time example for queues because one needs some development experience to do that. Tables is a NoSQL store. It's like NoSQL database presented by Microsoft Azure. The same will be used in Cosmos DB, an offering from Azure. So these two file systems we don't touch in this course, but blobs and files we'll discuss about them. Let's move on. So there are three types of access tiers in storage, Azure storage. One is a hot, the other one is cool, third one is archive. Hot is the data that is being frequently accessed will be placed on the hot tier. So if you have some virtual machine and which is a database server, so in such case the blobs or hard drives which belongs to that particular virtual machine can be placed in the hot tier. If it is a data that is not going to be frequently accessed, instead it is being accessed infrequently. In such case, it will be called as cold tier. For example, a hospital data, school data. So outpatient data will be hot. When the patient comes in and register himself, it will be hot data. And when he comes back for the follow-up, the data will be retrieved. Until then, that data will be in the rest phase. So that is called as cool data. And archive, if the patient is not coming back, he is completely healed, he don't want to come back. So he comes back after 1 year, but he has a record of his data from the previous year. So hospital does a backup of his data so that it can be preserved for a long time. So that is called as archive tier. So more than 30 days, cool tier, more than 180 days, archive tier, used for long-term backup, secondary backup, and archival databases. So now we have different types of storage accounts. Now the version 2 is available. Version 1 is also available. Version 1 has all the features from the beginning. Version 2 is having limited features. We are going to see that in the next slide now. Okay, so these are the types of storage accounts available. So these are all interview questions. Just be prepared well and go ahead for the interview. General purpose V2 are the latest version of storage accounts. So it supports blobs, files, queues, tables. They can recommend it for most scenarios using Azure storage. General purpose V1, legacy account type, blobs, files, queues, tables supported. Um, it's recommended to use V2 instead of V1 whenever possible, because performance characteristics and newest kind of hardware will be used in the background for V2. Blob storage, um, it only supports blob type storage, not files, not queues, not tables. So it only handles blob type of storage with premium performance characteristics. So if you have high transaction rates using smaller objects and requiring consistently low storage latency, if you want high performance, then you have to go for blob storage accounts. It's only specifically designed for blob storage. File storage accounts, if you want only file storage, then files only storage accounts with premium performance characteristics. So in the above two, there are 4 types of storage supported, and in the below two, specific type of storage is supported. Blob storage accounts, legacy blob only storage. So it's an older version of blob storage accounts. Don't get confused. Just have clear mindset and understand these things. The later 3 are specifically related to one kind of storage type, blob or files. There are no dedicated storage account types for queues and tables, which are included in the general purpose V1 and V2 storage account types. And we have several redundancy options for storage accounts. LRS is called local redundant storage. ZRS is called zone redundant storage. GRS is called geo redundant storage. GZRS is called as GeoZone redundant storage. It is under preview now. So what is LRS? A simple and low cost replication strategy. So data is replicated synchronously 3 times within a primary region. Synchronously means constantly, continuously. When you create a virtual machine, the hard disks belong to that virtual machine will be replicated 3 times. If it is a storage account based storage and it is set to configure, it is set to LRS, then 3 copies will be maintained for your hard drives within the primary region. Zone redundant replication happens between the zones, availability zones. Above is within the data center, within the zone, between the data centers. Zone redundant storage replication for scenarios requiring high availability. Data is replicated synchronously, again constantly, continuously, across 3 Azure availability zones in the primary region. The first one is between the data centers within a single zone. Second one is between the availability zones in the single region. Geo-redundant storage, it is cross-regional replication to protect against regional outages. Data is replicated synchronously 3 times in the primary region and then replicated asynchronously. Once the replication within the primary region is completed, then with a time gap between 5 to 10 minutes or 15 minutes, secondary region will be replicated. So whenever something goes wrong with the primary region, you will be losing at least 10 to 15 minutes of data because it is asynchronous replication. And if you want to enable read access to geo redundant storage, you can do that. By default, the secondary region doesn't having any read access. So if you want to enable that, you can use RAGRS option in there with additional charges. This is the new feature, GeoZone redundant storage. Replication for scenarios requiring both high availability and maximum durability. Data is replicated synchronously across 3 availability zones in the primary region, then replicated asynchronously to the secondary region. So it's an additional layer of high availability being added here. So if you want to get maximum high availability, maximum durability, in the first region, the data will be replicated between 3 availability zones and then asynchronously replicated to the secondary region. And again, if you want to enable read access for the secondary region, you can do that with additional charges. These are the redundancy options for storage accounts. And this is a table that explains all kinds of storage types, all kind of replication options, and supported access types, supported performance types. So one thing I forgot to mention here, there are two types of performance types available, standard and premium. Standard is supporting standard HDD, standard SSD. Premium is supporting premium SSD, Ultra SSD drives. And encryption is set to enable by default in the storage accounts. Managed disks, it's not yet supported. I think they started supporting disks created after 2017, something like that. There is a date being displayed there when you create the managed disks. When you create the managed disks, there won't be any storage account concept in there. It's all managed by Azure itself. So what are blobs? Blobs are the main data type in the storage, binary large objects. So Azure storage accounts actually support three kinds of blobs. So blob storage account is different. The types mentioned here are different. Don't get confused. So here, a storage account can support four types of file data, right? Blobs, files, queues, and tables. Now, within the blobs, if you want to store the data, there are three types of blobs available: block blobs, append blobs, page blobs. They have their own functionality. Block blobs supports up to 4.7 TB of single file. If you want to save a single file with such huge amount of data, you can do it using block blobs. Single file can span up to 4.7 TB terabytes. If you want to more than that, then you need to use page blobs. Page blobs actually can support up to 8 TB and can support random access. For that reason, all the virtual machine disks files, each virtual hard drive files will be stored as page blobs, because virtual machines reads and writes data randomly, right? And they use huge files for the drives. So the maximum size of the file that can be stored in page blob is 8 TB, and usually it is used for VHD. What are append blobs? Append blobs are usually used for logging purposes. So the data that's going to be appended all the time. For example, logging will be appended all the time. When something is happening, logs get generated. Log is only thing that gets, and mostly in most cases, log is the only thing that gets appended all the time. Data being written all the time. So for that purpose, append blobs are the best suitable things. Block blobs, again 4.7 TB. Any kind of data you can store in that as that kind. So I'll show you all these things in the demo once we move on to the demo. Azure blobs. So blob storage is ideal for serving images, documents to any browser, storing large files, streaming video and audio, storing backup and restore, disaster recovery, storing for analysis on premises. So logging and everything will be stored as blobs basically. Files only. Files offers fully managed file shares in the cloud that are accessible via industry standard server messaging block protocol, SMB-v3. So these are like SIF shares that we use in our Windows environments, network share things that we use in our Windows environments. Next, we have service endpoints. Once I'm done with the demo, I'll come back to this and I'll explain what is service endpoint that we left over in VNet concepts. So let's go to the storage accounts and let's go ahead and create one storage account now. So whatever we have discussed so far, I'll touch them here. So I'm going to create NextOps SG01. The name should be unique and in the small letters. Unique, it should be unique across Azure platform. It will verify throughout the platform, and if it is unique, then it will accept. Otherwise, it don't accept. Storage V2 and storage V1 blob storage. These are the three types available. If you select storage V2, you have options for performance type, standard and premium, access type, cool and hot, and also all kinds of replication options for the storage too. If you go to storage 1, you don't get cool and hot access types. It's only performance types and limited options for the replication. That is the reason why they are asking you to use V2 most of the time whenever there is a possibility. So version 1 only supports these kind of options. Let's go ahead and see blob only storage. It only supports blob type storage. V2 storage V2 supports all kinds of blobs, files, queues, and tables. Storage V1 also supports the same. Blob storage only supports blobs. And replication options are also limited. It doesn't have premium. It have access types. So let's go ahead and stick with V2 now so that we can touch all the options. I wanted to use it as read access geo redundant storage. That would be fine for us. So we can see all the options. And next, endpoints. Here is the option. So what I'll do is I'll leave this as it is now, and I'll come back to this once we're done with the demo of this particular thing. Secure transfer is required. So whenever you actually retrieve the data from storage account, data that is in rest, so you want it to be encrypted all the time. So then go ahead and enable this secure transfer. Even when you are retrieving the data from archive tier to cool tier, then to cool hard tier, the transfer will be from the different storage devices in the background. So such case also, if you enable this, the data will be encrypted. And Azure files, large file shares. If you want have support for large file shares, you can actually use this option, but the current combination of storage account kind performance replication does not support large file shares. So you need to change the storage account type and also the replication type. Maybe storage V1 will give you the required option here. Let's stick with LRS. Yes, now we got the option enabled. So it only works with V1 and LRS option. We don't want that anyway. It's a meaningful name. So let's go ahead and do read only GL. Next, and this has been disabled. Data protection by enabling the soft delete. Once the data deleted from the blob will be retained for at least 7 days, I believe, before it gets deleted completely. So by enabling this, you can protect your data. Data lake storage Gen 2, it is for the workloads which are running on big data analysis and data science kind of stuff. So it's a huge topic and different topic. So I'm not going to touch it right now. If you want to have support for storage data lake, then you need to enable this. And NFS v3, NFS is network file system. As Azure files, it is a file sharing option for Linux operating systems. If you want to enable this, you need to sign up for NFS with on the subscription basis. It will not be enabled by default. You need to sign up for NFS v3. It's a new feature, and if you want to enable that, you need to have subscription also. Next, tags and review create. Let's go ahead and create and take a look at our first storage account, how it does look like, and what exactly I'm talking about till now. So it's a lot of theory basically. So you need to remember all the concepts and there are a lot of interview questions coming out of this particular storage scenarios. So all these important points are mandatory to learn and to remember. Deployment is underway. I'll pause this recording and come back once it is done. All right, the deployment is completed, and let's go back to storage account and look at the options available there. So as we discussed in the slide, we have containers, file shares, tables, and queues. If you open container, you can actually create container. It's a logical object. You can give specific access to container. Within the container, you will be creating the blobs or data, whatever the data it is. I don't want to give anybody access to this, so I'm keeping it simple. And container one, within the container, we can actually upload the data as blob or page blob or append blob. Blob or blobs which supports up to 4.7 TB. Page blob supports up to 8 TB files. Append blobs are used for logging. So how do you want to upload? If you want to upload VHD files, you can actually use page blobs, and the block size you can select between the size mentioned here. And how do you want to upload this? You want to use it as hard data or cool data or backup data? You can do that using these access tier options. So these are all the options available for the blobs to be uploaded. And we have access control, access policy options. Let's go back to the overview page and see file shares. So file share, here you can actually create a share with a quota 024, that is 1 TB. And this is a share now. So if you want to connect to it, you can actually connect to it using this particular PowerShell script from any remote machine, so that it will be mounted as a drive inside your Windows machine. You can also connect to it from Linux or Mac OS if you want to mount this particular object. And you can take snapshots for the data on the shares, so that you can revert back to previous versions if you want to do that. And properties, it gives you resource IDs and all. Okay. And next we have activity log. Whatever has been changed on this particular storage account will be updated here. We have access control to give access to people, tags to sort this particular resource into respect to environment or something like that. Diagnose and solve problems. We have common problems for storage accounts also, so we can actually use that. You cannot delete my storage account, need help with import or export, my VM disk is slow. So if you click on respect to option, some recommendations will be given to you. Data transfer, how do you want to transfer the data? For example, you want to migrate your on-premises VM to Azure cloud, Azure storage. So based on this particular tool, you can actually, Azure actually recommends what is best for you. Estimated data to be transferred. If you have about 500 TB to be transferred, and you have about 5 Gbps of network bandwidth, and you want to do it once. So you can use all these options. AZ copy is a command line tool with which you can transfer the data, but it will take up to 12 days. So these are all options you have. So using this tool, you can actually figure out which solution is best for you to upload the migrate the data from on-premises to Azure. Events, if something like some alerts or maybe something is going on in this storage account, some files are getting deleted or some files are getting dropped from the web application. In such case, based on the data being generated, maybe you can configure an event uh, using logic apps or Azure function, or maybe virtual machine options, something like that, so that whenever an event triggered on the storage account, like if file is dropped, for example, some user has uploaded some data, some document, Word document, or resume, something like that. Immediately, it has to be processed and converted to some PDF, right? So once the document is been uploaded, then you can trigger Azure function to convert it into PDF format. So likewise, you can actually use the events here to automate the stuff basically. Storage Explorer is to uh, connect to storage account using a desktop application. Previously, it was a desktop application, but now it has been integrated into browser itself. Microsoft is trying to lift the OS dependency for all the apps. We saw Bastion option for VMs, which is like connecting to the VM from the browser itself using RDP, a secure tunnel to be created to the virtual machine. Likewise, Storage Explorer also has been integrated into the browser, with which you can actually upload and download data, manage file shares and everything from here itself. It's a graphical user interface basically. So in Windows, I think I have installed it some time back, Microsoft Azure Explorer. So the same tool has been integrated into the web portal now. This is the standalone tool and it's been integrated into web portal now. It is in the preview mode right now. All right, access keys are for the connectivity purpose. So these keys, there will be two keys, and These are the connection strings. If you want to connect to the storage from the code, or maybe if you want to map it as a network drive, then you need to use these keys to do that. So this is how storage account will be displayed. So all the information will be from the storage account will be built up and presented to you, the graphical user interface. And if you want to mount the file share on your Windows machine, you need to use this as password. You can regenerate these passwords using this refresh button, but once the regeneration is happened, the previous key will be invisible, will not be recoverable. Immediately it gets invalid and not recoverable. Geo replication, as we have enabled GeoZone replication, I think read access geo replication. Our primary location is East US and the paid region is West US. So our data will be replicated to West US as the secondary region here. So as we selected RAGRS, secondary region data will be having read access also. Next we have CORS. CORS is a HTTP feature that enables web application running under one domain to access resources in another domain. Cross origin resource sharing. So if you're having web application running under one domain like nextops.com and you want to share the resources with another domain like nextops.in, then this kind of this will be used. So allowed origins, allowed methods, allowed headers, exposure. So this is specifically related to the development people probably. Configuration, if you want to enable Azure data transfer disabled, premium kind, all the options can be actually changed from here. Encryption, if you want to enable the encryption or disable the encryption, you can do it here. Also, encryption keys. Microsoft actually manages the keys for you. If you want to upload your own keys, you can do that using this particular option. For the encryption, this is specifically. Shared access signature, this is a beautiful feature. So you can create shared access signature tokens on timely manner. Maybe those will be available till 1 hour, something like that, depending on the time you set, starting time and end time. So a URL will be generated to access this data. After 1 hour, the URL will get expired automatically. So whatever the data you wanted to give access to, you want to give access to blobs, files, queues, tables, you can give that as well. And what level of access you wanted to give, and what time you wanted to give, what key you wanted to use for this. So if you click on this, this is the shared access signature for each type of storage. Firewalls and virtual networks. This is where the endpoint connections will come into picture. I'll come back to this once we complete this discussion. Advanced security, again, security center been introduced into this particular option also. We have seen security center in virtual machines, virtual networks, and now storage. So enable advanced threat protection. So all the transactions being monitored on your storage account, if you have security center is enabled. Additional features will be available and some recommendations, security alerts, everything that we saw inside virtual machines and VNets has been presented here. If you want to change this to standard type, it's a different story. All right. So static website. If you want to host a static website, first of all, what is a static website? A static website is something which doesn't change based on the user actions. It is the same always, irrespective of the end user actions. It doesn't change at all. But nowadays there are no static websites. We don't see static websites more often. We see dynamic websites. So if you open some website for the first time, it displays some information. Then if you refresh it, it will change its look and feel and display some other information. That is dynamic. Static is displaying the same information every time. If you want to host such kind of website, you can place that information here, and the same storage account can be used to host a website here. Properties, we have the resources information, all the URLs for your blobs, your queue tables, so connection strings, everything will be gathered from here, resource IDs. And this is the URL for our blob service. This is the URL for our file service. When we connect to our file share using the private endpoint, you need to use this. I'll show that in a moment. Logs, we know about it to avoid accidental deletion. So I'm skipping a couple of things here because I've discussed these things multiple times in previous videos. If you haven't watched them, please go ahead and watch my previous videos also in this course. Export template is used for automation. To create these kind of resources, you can take this JSON template and deploy them using this template. And there are blades specifically related to blob service and file service, table service, and queue service, different types of storages. So containers, we saw that. We have created a container when we try to upload some data also. Here we have seen the type of blob and access type related stuff. So we can upload data directly from our machine here, containers. Custom domain. Now this particular blob container has a URL presented by Microsoft Azure, but I don't want to use this. I want to use my own domain name, like nextops.com, some storage/storage, something like that. If you have one, you can actually map it here so that you can use it directly here. Data protection, blobs after delete. After you delete data, it will preserve for at least a week, I think so, by default, if you enable this. If you disable this, immediately the data will be deleted from the storage account. Data protection provides you method to save and recover your data when it is erroneously modified or deleted by application or storage account user. That's how it is. Azure Content Distribution Networks is for if you want to stream something like YouTube videos or something like that on your website, you can create a profile here and upload streaming data so that it will take that data and process it accordingly and give you the best performance out of Azure cloud platform. So it is rapid and it is designed to send audio, video, images, and other files faster and more reliably to customers using servers that are closest to the users. Lifecycle management, this is a feature that you need to remember. Like I have some data. I want to move it to cool storage after 30 days. And then I want to move it to archive storage after 180 days. By creating this rule, storage account will be monitored for the data changes based on the last modified date. It will be moved accordingly to the different access types. The archive storage type is the least costly, and then comes cold storage, and costly is hot storage. So if you configure this, all your data will be migrated to archive data after 6 months. So you will reduce your storage costs basically. You can do that using lifecycle management options. And file shares, we have a share created, and we can also upload the data inside this. If you want to do that, you need to click on upload and just select your file from the machine and upload it. That's all. So tables, again, NoSQL database. Check out Premier Table Experience with Azure Cosmos DB. As I mentioned, it's part of Azure Cosmos DB now. Here it is. So if you want to create NoSQL database table, you can do that. What is NoSQL basically? So SQL data is organized. Like you'll be having rows and columns in which the table data will be organized actually. So you'll be having predefined fields and you can change it later on. You can append the table depending on the application requirements. But in NoSQL, what happens is the fields will be automatically appended. If one user comes and fills up the data with first name, last name, email address, 3 fields will be created. If second user comes up with first name, last name, email address, and phone number, immediately 4th row will be created within the table. And from there on, whoever enters data in the phone number value will be stored in that. Email address value will be stored in that. So it's not mandatory for all the users to have phone number field. It's not mandatory for all the users to have email field. If someone comes and adds one more value, that will be added to the table. That's how it is. NoSQL will be, there is unstructured data basically. It doesn't have any structure associated with it. Queues, it's basically used to send notifications and process the transactions within the pipeline. So like when you order something on the e-commerce website, taking the order, processing it, shipping, um, transaction, sending the notification or email, um, giving the invoice, etc., will be handled by queue storage basically. For such kind of transactions, queues can be used. Insights: how much storage is being used, what exactly taking, which amount of storage, kind of information will be presented here. How many IOPS has been generated so far, what is the latency, and what is the availability of the storage, kind of information can be presented here. So alerts, if you want to get alerted for something, you can actually create an alert. And also I forgot to mention in the previous video, there is an action group. In here you can actually add some actions so that automatically it performs that action and do the necessary stuff for you. For example, my file share is filled up, 1 TB I have associated with it, but somehow 90% of the data has been occupied and 10% I have. So I wanted to clean up something. Maybe I can take the necessary action here using these Azure functional runtime runbooks or whatever it is. You can do the necessary action on that and clean up some stuff automatically. So such kind of actions can be performed using rules, alerts basically. Whenever alerts get generated, also accordingly alert will be action will be performed. Metrics, again, performance related stuff. So what is the ingress data, egress data, how the transactions are being happened, what is the used capacity, everything will be shown here. Advisor recommendations, we don't see, we will see recommendations from Azure to enhance the performance of this particular resource, that is storage account. So Azure recommends to use managed disks whenever possible because it has lifted storage account dependency on the when you use managed disk. Managed disks also having availability sets. So as we configured availability sets for virtual machine, when you use managed disk, the same concept will be available for disks also. In the storage accounts, managed disks availability sets won't be available. So everything will be stored in the storage accounts as individual entities. So monitoring is the new here, and it is classic, old for the old people from the Azure Classic basically. Azure previous platform kind of uh, charts and stuff generated here. Resource health, how it is getting, how it is running, how the resource is running, is there any issues related to storage or anything like that will be generated here. Connectivity check, again, all it is trying to connect with other services within Azure, like using the SaaS tokens, shared access signatures. So few of them are connected, few of them are looking good, and Azure AD we don't have created yet, so it's failed. Obviously, for Azure AD for Q service also failed because we don't have Azure AD established yet. So it is trying to check the connectivity from all networks, whether it is accessible or not, kind of thing. And support request we have, which is related to Microsoft support. The last thing we need to discuss in this video is service endpoints. What are service endpoints? If you can see from the slide, virtual machine on the left side, service storage accounts on the right side. So both of them are different resources coming from the Azure platform itself. Earlier, when we wanted to connect a storage account from a virtual machine, like a file share from the storage account to be connected from the virtual machine, we need to use public endpoints over the internet. So that was a security concern for a lot of customers. So Microsoft has lifted the concept of public endpoints and came up with a solution called service endpoints, in which what happens is when you create a service endpoint for a specific resource within the Azure, you can actually access the resource privately from other resource. Be it be from different subscription, be it be from different region, you can access it privately without the need of internet, because at the end of the day, all these resources are actually residing on the Azure platform itself, right? So virtual machines from one subscription, storage account from different subscription. End of the day, they belong to Azure platform itself, right? So there is no need of connecting through internet from here. We can actually take advantage of the Azure backbone and do the secure communication to the needed resource. So earlier, in the first module, we have created a VNet with public subnet and private subnet, but we haven't associated any security group, network security group to the private subnet. And also we haven't placed any virtual machines inside the private subnet. So far we have public subnet and public virtual machine. We are connecting through public IP over the internet to that public machine, right? So what I'm going to do is I'll create a private subnet and I'll place a virtual machine without the public IP inside the private subnet, and we'll try to connect to the storage account within the subscription without the internet access from the private virtual machine. So by default, for every subnet or virtual network deployment, outbound internet access is default enabled. So what I'm going to do is I'll create a network security group for the private subnet and block the internet access and only allow the storage resource access to the private subnet. And also I will block the access to the public subnet to the storage resource. Public subnet will be having internet access, but so far we will be connecting to the storage platform using the browser. We'll be creating the shares and we'll be uploading, downloading the files within the shares using the internet as the backbone. So by default, our public vision will be having internet access, but we will be restricting specifically access to the storage account. So it should not access the storage account using the internet, but privately the machine in the private subnet should access without the internet. So that's what our goal to be reached. So let's go ahead and do that. For the comfortability of demonstration, I have created one more subnet inside a VNet. In fact, it has been created in the first module itself. So I have created a network security group and attached it to this particular subnet. The network security group is something like private NSG, and it does have rules, inbound rules allowing RDP access from within the VNet, and outbound rules like I have blocked the access to internet and I only allowed access to the storage from the East US region. So if we place any virtual machines inside this subnet, they don't get internet access by default. We have blocked it. Actually, by default, it is allowed, and that rule is having 65,001. To deny, I've created a rule with lower number to make it highest priority. So now these machines won't get the internet access. So without internet access, we cannot access the storage accounts earlier. But as we have removed the internet access from this subnet, how are we going to access the storage account? That's what we are going to see now. If you look at other security group public, which belongs to the public subnet, it does have inbound rule for RDP and outbound rule for internet access. So now I've already I've already created one more virtual machine called private VM. It doesn't have public IP associated with it. It only have private IP and belongs to private subnet. And the one which we are using from the beginning does have a public IP, and using which I have already established a RDP connection to that. If you can see the IP in the title bar, 40.121.220.201. The same is here, given here. So I have connected here, and from that machine, I'm going to establish RDP to the private machine. So this is the IP of our private machine. So by default, between the subnets within a VNet, the RDP access or any kind of access is allowed. We do not need to define any kind of rules there. So I am establishing RDP connection to the private VM. So as I have a blocked internet access to the private subnet, which also impacts the internet access within this VM because it belongs to the private subnet. And before that, while it is loading, let's go ahead and check the internet access inside our public VM. Yes, it is accessible. And also let's go ahead and see the access to storage account, whether it is accessible or not. So if we block the access to public subnet, you will see access denied error when you try to access the storage account and its components. So the access for the storage account, if you go to the file share, that's what I'm going to actually show here. So we can open the file share, and we can open the share, and we can download or upload the files now. We have access to it. If you want to upload something, you can do it. Browse through it, and you can actually do it via browser from the public machine. So this URL is actually accessible via internet, right? So now let me create a file. So maybe that makes good sense. Test from public subnet. I'm going to upload this file to the file share from public machine. Now it is accessible. Let's go ahead and do that the same way from private machine. As we have denied access to internet, it should not open the portal.azure.com in the first place because it doesn't have access to the internet. Let's open google.com first and check the internet access from this private machine, and then we'll check the other things. All right, internet is not accessible in this machine because it's taking longer than expected. So let's go back to our portal and go to the storage accounts, create a service endpoints now so that we can access the storage account within the private VM, not from the public VM. To do that, to enable that, basically you need to go to your service endpoints under the settings, firewalls and networks, because it has been allowed from everywhere. We are able to access from the public internet. We were not able to access from private machine because that machine doesn't have internet access. So let's go ahead and explicitly give access to the private subnet. So I'm going to choose my existing subnet network from the list. So it's been already added because I have done some testing prior to this demonstration. So I've chosen my private subnet and it's been already added. So what I'm doing with this particular wizard is I'm granting explicit access to specific subnet within the VNet, that is private subnet. And also, if you see here, if you want to restrict access to my laptop also from the machine that I'm managing, the portal.azure.com, if I wanted to block access, I can actually click on save. If I wanted to grant access, I just need to leave the entry here and click on save so that I can access it from my laptop also. So now I have saved my firewall rules, right? So I am explicitly granting access to private subnet, not allowing any other networks. Even the machine in the public subnet should not have access now. And I can access because I already added my machine here, right? So let's go back and verify the access. So it might take some time to get refreshed. See, now our public machine has been access denied because we have restricted access to only private subnet. But there is no possibility for us to access it from private VNet because we are unable to open portal.azure.com. So what is the way that we can establish this connection? We need to go back to our portal again and create a private endpoint here. So this particular private endpoint give access to storage account from public private subnet P01 private endpoint 01 and the East US region. Click on next. Resource type is storage account, and the storage account that I wanted to use is for my storage account name, and the target I wanted to give access to file share. Configuration, which virtual network you want to place this private endpoint in. I want to place it in VNet and in the private subnet. And there will be one DNS zone will be created to grant access via private endpoint. So this is the name of the DNS zone with which you can actually, with which your machine can actually connect to the storage account via private link. So let's go ahead and create this. It's going to take some time to create the private endpoint. But before that, let me go to the virtual network and VNet, go to the subnets. Okay, virtual networks, VNet, and go to the subnets. Private subnet we don't have. We only have one IP being utilized now for the virtual machine that is being placed in, that is private VM. Now what is going to happen is, while the deployment is going on, an additional network interface will be added to this particular subnet, and an additional network interface without machine skeleton. If you go to your network interfaces resource, wherein you can see the interfaces belong to which VM, private VM, and VM01 is a public VM. Now, with the creation of private link, an additional network interface will be added here, which doesn't get attached to any of the VM. Interface itself will act as an independent entity, independent resource here. Once the deployment is complete, you can see additional network interface here. So this interface will enable connection to the storage account on the other side. That's how the service endpoints and private endpoints concept actually works. So what we have done so far is we have created a subnet within the VNet that we have. Prior to this session, we only have gateway subnet and public subnet. Then I have added additional subnet, private subnet. To add this subnet, I clicked on this button and I filled in the details, and I have selected the service here, like Microsoft Storage. So this particular subnet is having access to Microsoft Storage service. So that's how I have explicitly granted access initially. And then I went ahead to my virtual machines and created a virtual machine inside the private subnet. Storage accounts can be accessible via public URLs because by default they can be accessible via internet. If you go to the properties section of this particular resource, you can see public URLs for each service, blob service, file service, queue service. File service, we have this one, right? So by default, they will be accessible via internet. So now I don't want to access them through the internet. Instead, I want to connect through the private link so that the communication will be secured. In order to do that, I have created a VNet, private VNet, and placed a virtual machine inside that and created network security group which prevents access to the internet and allowed access to storage accounts, which prevents access to internet and allowed access to storage accounts. So now my private machine doesn't have access to internet. So it cannot access portal anyway. But my public machine, it does have access to internet. It can access portal.azure.com. It can browse to the storage account and it can access the file share inside the storage account and it can upload or download whatever it is. But now I wanted to restrict the access to machine in the public subnet, even though it is having internet access, and grant access to the machine which doesn't have internet access. To do that, I have actually went ahead and created a service and endpoint on the storage account side. And first, initially, I have granted access using firewalls and virtual networks, wherein I have selected my private subnet. So as we saw, we were unable to access a file share from the public machine. It's been denied now. It's been denied now. But from the virtual machine, if we want to access, we don't have internet access in the first place itself. So we need another way of connecting to the storage account from the virtual machine in the private subnet. To connect to that, we are creating a private endpoint here. Creating a private endpoint does mean creating an additional network adapter in the subnet that I wanted to access from. So if you go to your private subnet from your virtual network and subnet section, you now have one other IP consumed. Earlier it was 250, now it has become 249 because an additional network interface card has been added. Let's go ahead and see that now. If you see here, there is a PE01 interface has been added in the private subnet because 10.0.2 series belongs to private subnet and it is not attached to any VM as the other network cards. So once the deployment is completed, we go to our private machine. We go to our private machine and mount the network share. Any cause we're not able to access the portal.azure.com because we don't have access to internet. So we have granted access using the private link, using this interface. Now we need to figure out a way to mount this particular network file share on the private machine. So in order to connect to this, Azure will give you a script basically. So if you want to connect to this share, you need to click on the connect button and take the script, copy the script, go back to your private virtual machine, and open PowerShell ISC console. If you want to understand how PowerShell works, just go ahead and watch my PowerShell videos. And paste the script that we have copied. So this is our storage account name and this is our key. So I'm going to execute the script now. So the file share will be mounted. Just give me a moment, guys. I think the deployment is finished now. So let's go ahead and execute the script. So we are not accessing the storage account through the internet. We are accessing it using the private endpoint that we have created. So if you see here, there is a drive attached to your private machine, which is coming from the Azure. And if you open that, you can see the file that we have created from the public subnet. And if you create a file here, test file from private subnet, we have created the file. And if we go back to our share and refresh, we can see the file that has been created from the private subnet. And if you go back to your public subnet, even though you have internet access, you still not be able to access it. So this is how service endpoints actually works. And the same concept can be applied to any of the services like SQL or any of the other services which supports the service endpoints. Again, I'm repeating, this is a public machine which have internet access, but explicitly we have restricted the access to storage account, and we granted private access from the private machine, and we were able to mount the network share from the Azure using the private endpoint. This machine doesn't have internet access, but it is still able to access the network file share. So this is how service endpoints actually works. If you have any questions or anything like that, please drop a comment in my channel, so I'll respond accordingly. If you haven't subscribed to my channel, please go ahead and do that now to receive the updates via notification, and do not forget to click on the bell icon. I hope this video is informative to everyone. If yes, please go ahead and subscribe now. Thank you so much.